Good afternoon, class. Yesterday, we tackled about the domain and the range of rational function. So this time, we are going to tackle about the inverse of a function. So before we go deeper with our discussion for this afternoon, I wanted to complete the table. I'll be giving you 1 minute to do it. Your 1 minute starts now. Okay, time is up. Can we have Lawrence? Lawrence, can you give me the f of x in letter A?
So one more time. So if the value of x is negative 3, the value of y is 1. If the value of x is negative 2, the value of y is 2. If the value of x is negative 1, the value of y is 2. If the value of x is 0, the value of y is 4. If the value of x is 1, the value of y is 5. If the value of x is 2, the value of y is 6. And if the value of x is 3, the value of y is 7.
Fantastic. Fantastic, Lawrence. Thank you. Can we have Vincent Bispo for the second function?
The value of x is 1. If the value of x is 7, the value of x is 2. If the value of x is negative 1, the value of x is 0. If the value of x is 2, the value of x is 4. If the value of x is 1, the value of x is 5. If the value of x is 2, the value of x is 6. And if the value of x is 2, the value of x is 7.
Okay, very good. Thank you, Vincent. Now, as what Lawrence mentioned, here are the values of f of x when the given possible values of x are from negative 3 to 3, and the resulting values of f of x or the y are from 1 to positive 7. And as mentioned by Vincent Angelo, when the given g of x or the y is from negative 3 to 3, the values of the x will be from 1 to positive 7. I want you to take a look with the resulting table. Children, can you give me your observation? What observation can you make out of the given table?
Value of x of x, the first thing called value of x.
Maybe you're pertaining to the x and the g of x. Am I correct? And then the f of x, they have the same value as x. Am I getting the correct answer? Okay. Now, for letter A, we have there f of x is equal to x plus 4. Can you give me the domain in letter A, Francis? The domain and the range.
The main letter is x is greater than negative 2, but less than
Greater than,
greater than or equal to negative, but equal to negative 3,
okay,
but less than or equal to 3.
that's correct. What about the range,
And
Francis?
for the range, y is greater than or equal to 1,
Okay,
but less than or equal to 7.
very good. Now let us have letter B. G of x is equal to x minus 4. Can you give me the domain and the range, Emmanuel?
For letter B, the domain of the function is x is greater than or equal to 1 and less than or equal to 7.
Good. The range is,
The range is y is greater than or equal to negative 3, but less than or equal to 3.
that's right. Now, take a look with the domain and the range of the two given functions. What have you noticed? Julian, do you have some observation about the domain and the range of the two given functions?
I have noticed that the domain of the first function is the range of the second function. The range of the first function became the domain of the second function.
Very good. The domain of letter A, the given function in letter A becomes the range of the second function and vice versa. And what can you conclude with the two given functions? Anyone? Julia, you're raising your hand.
Um, since their domain and range are somehow similar but interchanged, I can infer that they are inverse functions.
Okay, now for us to conclude that the two functions are inverses, let us first take a look with evaluating f of g of x, and the second one is g of f of x. So for the first one, we have x plus 4, and our g of x is x minus 4. So this will be x minus 4 plus 4. And the f of g of x is equal to x. The second part, this will be x minus 4, and f of x is x plus 4. This is x plus 4 minus 4. So we have now x. So when we evaluate f of g of x and g of f of x, the result is x. Now to verify Julian's conclusion that the two functions are inverses, let us take a look with the given function. If y is equal to f of x and f of x is equal to 3x plus 2 times, this is read as the inverse of x to verify the conclusion or observation earlier. Now, for us to find the inverse of 3x plus 2, the first step is to change f of x to y. So let's change f of x to y. And then the second is interchange the possession of x and y. So that's interchange x and y. And then last is to solve the value of y in terms of x. Solve for y in terms of x. So we have there to solve y, so we have to eliminate 3. To eliminate 3 is to divide both sides by 3. So x minus 2 over 3. And the last one is to change y to f inverse of x. So f inverse of x is equal to x minus 2 over 3. Clear? So take a look with the steps. Change f of x to y, interchange x and y, solve for y in terms of x, and the last one is to change y to the symbol f inverse of x. Okay, question so far? Okay, very good. So we cannot define inverse function as let the function f and g be the two functions such that f of g of x is equal to x for every x in the domain of g, and g of f of x is equal to x for every x in the domain of f. Then we say that the function g is the inverse of the function f. And we denote g by this one, f inverse, and f of inverse of x is equal to x, and f inverse of f of x is equal to x. So the domain of the f or the original function will be the range of the inverse and vice versa. The range of the original function becomes the domain of the inverse function. Okay? So let's apply that definition and the steps of finding the inverse in example number 1. So first step is to change f of x to y. So that's 3x minus 1, 2x plus 5. So change f of x to y. Then interchange the possession of x and y. So interchange x and y. Then solve for y in terms of x. So we have there x to y plus 5 is equal to 3y minus 1 all over 2y plus 5. So we have there the LCD as 2y plus 5. So solve for y, sorry for that, in terms of x. Okay, so we have there 2xy plus 5x. We multiply this is equal to 3y minus 5. Let me write this one on the last part. That's 2xy plus 5x is equal to 3y minus 1. Then since we have to solve for y in terms of x, so we have the 2xy. I still have 1y here, and then negative 5x minus 1. We can solve this using factoring as the common monomial factor. So the common there is y, 2xy divided by 2x, sorry, 2xy divided by y, that's 2x, minus 3y divided by y, that's 3. That's negative 5x minus 1. And then to isolate y, you have to divide both sides by 2x minus 3. So our y is negative 5 minus negative 5x minus 1 all over 2x minus 3. The last step is to change y to its inverse x. So meaning to say the inverse now is negative 5x minus 1 all over 2x minus 3. Okay, now let's try to find the domain of the inverse. What's the domain of the inverse? I saw Sildred. Are you raising your hand, Sildred? What's the domain of the inverse, Sildred? That's correct. Except 3 over 2. So all real numbers such that x must not be equal to 3 over 2. Okay? Now, what's the range? Remember the definition of the inverse? The range is the domain of the original function. So what's the inverse of what's the range rather? Vincent, Angela. That's correct. So meaning to say, the domain of the f of x here, domain is vice versa. We have x, all real number such that x not equal to negative 5 over 2. And the range will be, we have all sets of real number such that y not equal to 3 over 2. Clear? Okay, let us have example number 2. The given function is x squared plus 4x minus 2. Find the inverse if it exists. So first step, you change f of x to y. That's x squared here plus 4x minus 2. And then the second step will be interchange the possession of x and y. Y becomes x. We have there y squared plus 4y minus 2. I forgot to change f of x to y. And then interchange x and y. Then the third step is to solve for y in terms of x. So we have there x minus 2, y squared plus 4y. Solve for y in terms of x. Now, as you notice, the right side is y squared plus 4y. Basically, when you are going to factor out y there, it will make our solution um, it's useless. It doesn't make sense if we are going to factor y there. So all we have to do is to make the right side a perfect square trinomial. So we'll be needing here the concept of completing the squares. So as we all know, completing the squares, to make it a perfect square trinomial, you have to add 1/2 of b and its squared. Our b is 4, half of it is 2, square, that will be 4. But to balance the equation, you have to add also here 4. Okay? So this will be, I think this is plus 2. Kasi the other side is negative. So it's x plus 6. This is a perfect square trinomial. When you are going to factor out, that's y plus 1 and b squared. Okay? So it's x plus 6. Solving for y now, we have y plus 2 quantity squared. So our y will be, it's y plus 2 is equal to the square root of x plus 6. So y is equal to negative 2 square root of x plus 6. The last is to change y to if inverse of x. I want you to notice the resulting inverse of the function. Vincent, you're raising your hand. What is your observation? Um, y is equal to negative 2 square root of negative 2. Yeah, for negative 2. Now, when we are going to get the square root of a certain number, say for example, square root of 16. What is square root of 16? Julian? Yeah, positive negative 4. So when we get the value of the square root of x plus 6, what do you think will be the result? Knowing you have the value of x, there will be two values inside when you are going to extract the radical sign. So which means that the inverse of the given function, which is negative square root of x plus 6, meaning this one is not a one-to-one function. Remember, we only have the inverse of a function if the given function is a one-to-one function. However, there are functions which are not one-to-one. There is a resulting inverse function, but that function, when you are going to graph them, when you are going to analyze, it is not a one-to-one function, meaning the function, the inverse function does not exist. But we have to restrict, when you are going to restrict that the x will be greater than 0, then this function will become, the inverse will become defined. Okay, remember, we only have the inverse of a given function if that original function is a one-to-one function. Here, we have two values of x, taking one value of y, and this is not a one-to-one function. Okay? Now, it's your turn. I want you to show that f of x is equal to if f inverse of x is equal to x over 3. Okay, I'll give you 15 seconds. Is it enough? There are many ways how to show if the two functions are inverses. You can use the definition or you can use the steps. Can we have Emmanuel? Emmanuel, what's your process or what's your uh, how did you solve? How did you show that the two functions are inverses?
To show that the two functions are inverses of each other, I substitute the value of the other function to the value of x of the other function. So getting f of x times x over is equal to x.
Okay, so you are getting the f of negative 1 of x. Am I correct? And then,
Vice versa.
okay, is equal to,
Is equal to 3x is also equal to x. Therefore, functions are inverses of each other.
therefore, f of x and f inverse of x are inverses of each other. Okay, now, questions so far? No question. Let's proceed. Very good, thank you. Let's proceed to your um, practice exercises. So pair one will be Francis and Angelo. Pair two will be Lawrence and Ison, Julian. Pair number three will be Emmanuel and Zildred. I'll be giving you 2 minutes each. Okay, time is up. Your 2 minutes is up. Let's start with Francis and Angela. Anyone from the two of you who wants to share? Francis, go.
I think for you will find f of g of x and g of x.
Okay.
So for f of g of x, we can q of x,
You
multiply x, x minus 1, multiply q plus 1. So, and then the since it's cube, it is cube, it will be cancelled.
okay?
So
The index, the exponent. That's good.
it will be x minus 1 plus 1. Therefore, f of g of x is equal to x. And for g of f of x,
Square root, no?
cube x minus 1. So, cube root of the 1
Okay.
minus 1.
X cubed, sorry, plus 1 minus 1. Okay, this will be
So, in the cube root of
x cubed.
1 and -1 will be cancelled.
That's good.
Therefore, g of f of x will be equal to x.
Very good.
And that shows the function
Fx and g of x are inverses. Therefore, okay, let's hear from Lawrence and Eason for number 2. How did you solve number 2?
So the question is, which of the following functions is the inverse of the function f of x is equal to 1 over 5x? So the easiest way for us to find the inverse function of this original function is to simply substitute the choices, since there are only two choices given problem.
10.
So after substituting the first option to the original function, the result will be 1 over x, which means that it's not the inverse function of the original function, and so you try the second option. So the solution will be h of x is equal to 1 over 5
Is
times
h of x
yes,
1 over
h of x is equal to 5 times 1 over 5x.
okay?
So we will cancel 5 since yes, that's right.
And then
So the 1 over 1 over x will remain, and if we simplify it,
that's
we will it will be x.
very good. So you are evaluating h of f of x. Okay, so h of x is the inverse of f of x. Very good. Last one, from the group of Emmanuel and Zildre. Emmanuel, can you do it? We still have 2 minutes class before your next class. So let's make it fast.
Getting the inverse of g of x equals 3 minus 4x.
Okay.
Let's substitute g of x for
Okay.
y is equal to 3
Correct.
minus 4x, and let's interchange x and y. So x is equal to 3 minus 4y.
Okay.
Transposing the different terms into y is equal to 3 minus x.
Okay.
Then divide both sides by 4.
That's good.
Apply that answer y equals 3 minus x over 4.
So this is the inverse. Sorry. So for the second one, make it fast.
For the second one, so that y is equal to x minus 1 over 6.
Okay.
Interchange x is equal to y minus 1 over 6. Then first multiply 6x equals y minus 1.
Okay.
Transpose 1 to the other side. Y is equal to 6x plus 1.
That's good. Very good.
Of the function is 6x plus 1.
Okay, that's very good, Emma. So the inverse of h of x is equal to 6x plus 1. Questions so far? Very good. So I want you to complete the following statement. Let's start with Julian. Julian, number 1. The inverse of a function is obtained by Julian.
The function is obtained by interchanging the xy pair of the function.
And then
We interchange x and y in the equation and solve
That's correct. Let's have number two, Francis.
Number the domain of the universe is the region of which
Very good. Let's have number three, children. That's good. So actually, those are the steps in finding for the inverse of the given function. Are we all clear? Do you understand how to get the inverse of the given function?
yes, oh, yes,
Okay, very good.
yes,
So that's all for today. Thank you for joining the class and see you tomorrow.